Okay, so we're trying to find how many moles of chloride ions, which are Cl minuses, are in 11.1 grams of calcium chloride. So our formula, first of all, is we're given mass, so the first thing that must happen is that must be converted to moles, which is mass over mR. So we have 11.1, and the molecular mass of calcium chloride, when you work it out, mR of Cl2 is equal to 40 plus 2 times 35.5. Now be very careful when you're picking up chlorine that you pick up 35.5, and the same copper is 63.5. So over 111, so that gives me 0.1 moles. Okay, now if we look at our equation, then we can see there are our formula. If I had one molecule of calcium chloride, it would contain 2 ions. So to write that in terms of moles, if I had 1 mole of CaCl2 molecules, that would contain 2 moles of Cl minus ions, because every one of these requires 2 moles of chloride ions. So that means we take the 0.2 moles and times that by 2. So that means we have 0.2 moles of Cl minus. Okay, now the next one. How many neutrons are there in 0.14 grams of carbon-14? So first of all, we have to figure out the number of atoms that we have. Okay, so that's the first thing we need to do. Now they tell us that carbon-14, so that means then it has a mass of 14 grams. Okay, 1 mole of it has. Okay, and also as well here, what we know is that the other thing we know here as well is that it has 8 neutrons. Okay, because if you subtract 6 from 14, you'll get 8. So our formula, first of all, we'll have to figure out how many actual atoms we have, first of all, and then each one of those atoms contains 8 neutrons. So if we go N equals mass over mR, we're going to have, now be very careful here that you take the 0.14 for the mass we're given, but make sure you divide it by 14 and not 12, because they did tell us it's the carbon-14. Okay, so that's really important. So that means we have 0.01 moles. Okay, now that's of carbon atoms. Okay, because carbon is made up of atoms. Okay. Now, so the number of atoms then is equal to the number of moles. I should be writing this in red because it's our formula, just to make it stand out. So the number of atoms equals N multiplied by Avogadro's constant, which is 6 by 10 to the 23. So we have then that N is 0.01 times 6 by 10 to the 23, and that's going to give me 6 by 10 to the 21 atoms. Now, so like we just said then at the start, each one of these atoms of carbon-14 contains 8 neutrons. Okay, so what we need to do then is we need to multiply this by 8. Each atom contains 8 neutrons. Okay, so that's getting from 14 minus 6 equals 8, because this is a carbon-614. Okay, so that means we have 8 multiplied by 6 by 10 to the 23, which is going to give me 4.8 by 10 to the 22 neutrons. Okay, so how many atoms of iron are there in a 30-gram bowl of cornflakes that contains 0.024 grams of iron per 30-gram serving? Now, this was an exam question here, and the first thing we must remember is this 30-gram bowl of cornflakes, okay, and here, that has nothing got to do with the question, okay? There's no relevance here in the question. That's just talking about what a human would take in the 30-gram bowl of cornflakes. Okay, so if you read the question without that in it, it would say how many atoms of iron are there in 0.0024 grams of iron, and that's it. Okay, so the rest of it really is just there to kind of make it a little bit more confusing and to see can you figure out what you're meant to be doing. So like everything, if I'm given grams, the first thing I need to convert to is moles. That's the most important thing to remember. We must always start with moles, okay? So again, I'll write my formula. N equals mass over mR. And then that's equal to 0.0024. And the mass of iron is 56. We work that out, then we get 4.286 by 10 to the minus 5 moles. Now it'll probably give you that one on the calculator because the number is quite small and awkward, okay? And at this stage, because it's minus 5, it's probably easier to give it as in scientific notation like that, because you can lose quite a lot of decimal places if we don't. Now it's really important that you keep that figure in the calculator for the next part of the calculation. Now, the next thing we want to figure out is that's how many moles of iron atoms that we have. But now to figure out the actual number of atoms, we need to use our number of atoms equals n multiplied by 6 by 10 to the 23. And that's going to be equal to 4.286 by 10 to the minus 5. Multiplied by 6 by 10 to the 23, and that's equal to 2.57 by 10 to the 19 atoms. Okay, now just be careful, like I said, to keep those figures in your calculator because you lose a lot of accuracy if you press the clear button between one calculation and the other. Okay, then the last one that you had, same type of question, okay? Exact same type of question, except for this time they didn't start mixing things up with bowls and serving sizes. And they're saying here that the daily recommended serving is 0.014 grams. Okay, so obviously some more than the previous one. Okay, so let's have a look. Again, our formula is N equals mass over nR. So like in all these questions, our first important thing is that we would convert to moles. And that's 0.025 moles, or that's 2.5 by 10 to the minus 4. Okay, and then we're going to convert this to atoms. So number of atoms is equal to n multiplied by 6 by 10 to the 23. So that's equal to 0.00025 multiplied by 6 by 10 to the 23. And working that out, we get 1.5 by 10 to the, 20 atoms.